Hello, ladies and gentlemen. Welcome to Chapter 10. We are on estimating with confidence. We're going to be finally getting into some of that inference. Now, ladies and gentlemen, before I begin, I'm just going to warn you, this video is going to be a bit long. If you need to, stop, take a break, pause, okay? But make sure you watch the whole thing. All right, before I get into everything, I do want to go ahead and pull up on Schoology, ladies and gentlemen. Right above this video, there's table B that I'm going to be talking about. There's the formula chart again, inference toolbox, you'll see that in the video, and then the example I'm going to do at the end if you want to print them. Again, there are some videos underneath that are dealing with this on the College Board website. Please click on those, log into your College Board, and watch them. Highly recommended. All right, there is one against all odds video in this section, so please watch that, take Cornell notes, answer some questions. There will be a day 2 on this. All right, ladies and gentlemen, let us begin. So, Chapter 10.1 is the basics of confidence intervals. So we are getting into the statistical inference that provides methods for drawing conclusions about a population from sample data. All right, so methods. Think about it. We got to follow a certain method in order to draw conclusions. Okay, this is where we really get detailed about things. All right, and there's lots of things you're going to have to memorize. Okay, on page 622, remember to read your textbook, folks. On page 622, it talks about the confidence interval and confidence level. A level C confidence interval for a parameter has 2 parts. Okay. A confidence interval calculated from the data, usually of the form the estimate plus or minus the margin of error. Okay, we'll get into more details in a little bit. A confidence level C, which gives the probability that the interval will capture the true parameter value in repeated samples. That is, the confidence level is the success rate for the method. Okay, the confidence level is the success rate for this method. All right. Now, going back, ladies and gentlemen, back to advanced algebra. Okay, sorry that this picture is a little slanted, but that's the way that the photocopy was. If you remember back in advanced algebra, we talked about margin of error. Okay, so this part right here, margin of error. And if you recall, this is the formula that we learned. When a random sample of size n is taken from a large population, the margin of error is approximated by this formula. Okay, again, it's approximated. All right, margin of error is plus or minus 1 divided by the square root of n. That's what we did in advanced algebra. Now, in AP Stats, we will use different formulas for the margin of error. Just realize that. But I'm going to use this to talk about something that is currently going on in our lives. Okay, the COVID-19 vaccines. Okay, we've got those 2 main vaccines that are out there right now, the Pfizer. Now, I did a little bit of research. I didn't find everything I wanted, but in what I did find that they did a sample size of 44,000 people. Okay, that is huge. That is huge. And they have a 95% confident of its effectiveness. Now, if I do the margin of error here, ladies and gentlemen, according to what we did in advanced algebra, and I'm just going to use ME for margin of error, that would be plus or minus 1 divided by the square root of 44,000. Okay, well, let's see what that gives us. So if I did the 1 divided by the square root of the 44,000, I'm going to get 0.0048. Okay, 0.0048. Now, if I change that to a percent, that would be 0.48%. That's the margin of error. Now, what is that saying? Okay, well, they're 95% confident of its effectiveness. That's my statistic. Plus or minus the 0.48%. So we can find, again, this is an estimate, and I couldn't find their actual standard deviation, folks, so that's why I'm using the advanced algebra one. Okay, so that would be, so our confidence interval would be 95.8% for the high end, and if I subtract that 0.48, that's 94.52%. Now, when we write confidence intervals, we actually make them look like ordered pairs. So if we go with that margin of error in there, ladies and gentlemen, we're going from 94.52% to 95.48%. That's excellent. That's really, really, really good. Okay, now, the Moderna, they had a sample size of 30,000. So I'm going to go ahead and do my margin of error, 1 divided by, now again, this formula is going to change for us. Okay, this is the formula that we used back in advanced algebra. All right, now if I take that one and find that, let's see, 1 divided by the square root of 30,000, and we get 0.0058. 0.0058, and we're going to go ahead and make that 0.58%. All right, now if I do the 95%, because they're also saying that theirs is 95%, they're 95% confident. So 95% plus or minus the 0.58. That's going to give us a confidence interval. Notice that 95%, ladies and gentlemen, that is the middle. Okay, that's like the mean of the two numbers we're finding. Okay, so here we get the high end would be 95.58%. And if I subtract it, that's 94.42%. So that interval is a little bit wider. Okay, there's a smaller low end and a higher upper end. Okay, but they're both 95% confident in their vaccine, which is excellent. All right, let's keep going here. So for us, the margin of error is going to be made of 2 parts. Okay, it's going to be made of 2 parts. There's the critical value. Okay, and that depends upon what percent accuracy you want. And then the standard deviation. Okay, the standard deviation of the statistic. So our confidence interval is made actually of 3 parts. We've got the statistic, plus or minus the critical value, and then the standard deviation of the statistic. Now, this is how it looks on the formula chart. Okay, so let's look at the formula chart. So right here is what it gives us, folks. Just what I had on that page. The statistic plus or minus the critical value times the standard deviation of the statistic. Okay, it's actually a very easy formula to use, but then at the end we've got the formula is super easy to use, but there's all kinds of, remember the method? We got to go through a process, okay, and you'll see. We'll get there, all right? Don't want to get ahead of myself. All right, wrong screen. There we go. All right, so let's keep going here. Now, let me make this a little bit smaller for the moment. So confidence interval for a mean. if we know the standard deviation, remember this is sigma, ladies and gentlemen, we know the parameter, we know the population standard deviation. But please remember, it is not realistic to know that. Okay, so then we will use S, but we're not going to do that right now. Okay, we're going to be doing some problems where we actually supposedly know that standard deviation. So today we're going to concentrate on this one, where the population standard deviation is given to you. Okay, our statistic is the X bar because we're doing means right now. The Z star, that is the critical value, and then the standard deviation divided by the square root of n, remember n is your sample size, that is your standard deviation. Now, when we get to chapter 10.2, we're going to redo the formula a bit, and we're going to have a T star there. It's still a critical value, but there's a different way we got to find that number. And then S is the sample standard deviation. Okay. Now, when we get to chapter 10.3, we're going to be doing proportions. And so the confidence interval is going to look like this, where we've got P hat, because remember, proportions uses P, and a sample proportion is P hat. And Z star, the critical value, proportion uses Z star. Again, there's so many fine details here we got to watch out for. And then the standard deviation is going to be the P hat times the complement divided by the square root of n. But more of that when we get to that chapter. Now, our critical values, ladies and gentlemen, are these are the three most common critical values we use. Now, you're going, what in the world? I don't understand what you mean by critical values. Okay. If we're wanting a 99% confidence interval, well, I don't want to do that quite yet. Our Z star is going to be 2.576. Okay, I'll show you that in a little bit. 95% confidence interval, the Z star is going to be 1.96. 90% confidence interval, Z star is going to be 1.645. Now, we can find these on table B. Let me show you on table B. You can print this. If you go all the way, we have not used this table yet. This is brand new. And all of this stuff you see right here, ladies and gentlemen, that's going to be chapter 10.2. I'm going to be showing you how to use the table with that. But if you go down to the very bottom, the last row is infinite. Okay, 95%, here is your critical value, Z star, 1.96. Okay, 99%, they've got all kinds of percents here. We don't just use these three, sometimes we might have to use another. Our critical value, our Z star is 2.576, and then here's the 90 that I showed you, 1.645. Again, that's at the bottom of this table B for your critical values. Okay, now you're probably going, I don't know what those are. Okay, I'm going to show you here in a little bit. All right, so those are the most common, and usually students memorize those. Okay, but if you don't, you can always find them at the bottom of table B. And you got to go to the infinite. Again, the rest of the table I'm going to teach you in chapter 10.2. All right, so let's see where these numbers actually come from, ladies and gentlemen. Now, I'm going to just start with the 90%. Again, the 90% confidence interval, the Z value is 1.645. Okay, so let me show you. So if I want 90% confidence, ladies and gentlemen, that means, well, maybe not quite that far over. Let me go like right here. Okay, 90% means I'm going to have 90% of the data in the center. That means 5% in this tail is left, 5% in this tail is left. Now, the Z, the critical value, the Z value here is 1.645 and negative 1.645. Oh. So if I go from negative 1.645 to 1.645, that's 90%. Just to demonstrate that, folks, let me pull up the calculator and let me go to the normal CDF. All right, I'm going to put negative 1.645 to positive 1.645, and you will see, ladies and gentlemen, it's 90%, 0.90. Isn't that cool? So those are the Z values, folks, the positive and negative Z values. Those are the critical values, okay? Those are the critical values. So the 95% is going to go a little bit further, okay? And if I go back, okay, see 95% is 1.96, all right? So that would be negative 1.96 to positive 1.96. So 95% of the data is contained in there, which leaves 2.5% left in each tail. Okay, and again, I could do that on the calculator, but this video is going to be long enough, so I'm not going to show you. If you want to, go ahead. And then the 99% confidence interval, ladies and gentlemen, that's going to go almost the whole thing, right? There's 0.5% left in this tail. There's a 0.5% left in this tail. Okay, and then the value, so if we go back, that is 2.576. So that would be positive and negative, negative 2.576 and positive 2.576. And again, ladies and gentlemen, that is on your table right there at the bottom, table B. Okay, again, if I'm going too fast, please pause, rewind. All right, let's keep going here. Now, what does 90% confidence mean? Okay, time for me to pull up another applet here. All right, let's take a look at this, ladies and gentlemen. So let me move this to 90%. There it is. And I'm going to do a sample size. Oh, I'm just going to leave it at 20. All right, now I'm going to go ahead and pick a sample, ladies and gentlemen. And so you see all these little dots. Okay, that's 20 samples, and then we did an interval. And so let me just do a whole bunch of these. So I'm just going to keep going. So there's a sample of 20. The dot in the middle, that is the mean. Okay, that is the mean. And we're going to, okay, so you see the black line? So I'm at 90% confidence, right? Let me go back here for a second to my 90%. So remember, 90% goes to negative 1.645 deviations to the left and 1.645 deviations to the right. Okay, 90% goes from that deviation to that deviation. So the black line that you see, ladies and gentlemen, that is going from the negative 1.645 to the positive 1.645, and that black dot is the mean of those 20. So if I keep doing that, oh, then I got a red one. You'll notice, so in the center is our true mean, right? The population mean. Okay, that one is red. That means that interval did not capture the mean. If you look at these other ones, 1, 2, 3, 4, 5, 6, the 7 that I did, those 7 captured the true mean in that interval. Okay, the mean in the sample doesn't necessarily match exactly the mean of the population. It usually doesn't, folks, because you're taking a random sample. So that interval did not capture the true mean. Those 20 did not capture it in that interval. Okay, that one did, and so on. Okay, and I could keep, you'll notice most of them are black. Okay, pretty cool. Oh, then I got 2 in a row that are not. Those 2 did not capture the true mean in that interval. Okay, so again, if I take a sample of 20 and the mean is right here, and then I do my standard deviation, negative 1.645 to positive 1.645, as I do that most of the time I'm going to capture the true mean, but sometimes we will not capture the true mean in that interval. Okay, so this is we need to write this down. The confidence level of 90% indicates that in repeated sampling, intervals constructed in this way will include the true population mean 90% of the time. Okay, you might want to pause and write that down because I'm going to keep going here. So hit pause if you need to. So if I did this 100 times, that confidence level should capture the true mean in that interval 90 out of 100 times. Okay, 90 out of 100 times. So let me do reset, and I'm just going to do sample of 25. Boom, there's 25 of them. Okay, I'm going to do 25 more. Boom. Oh, it's only going to do 25 at a time. Okay. So let me reset. So here we go. 25. Boom. Okay, 2 missed. 25 more. 1, 2, 3 missed. So I'm up to 5. 5 out of 50. Here we had 1. So 6 out of 75. And then 7, 8. So in this one, there were 8 times out of the 100. Okay, 90. Oh, it says it right here. 92 out of the 100. So it hit 9. It captured the true mean 92% of the time. But it's at a 90% confidence level. All right. Whew. Got your head wrapped around that? Okay. So 95%. Okay, same thing, ladies and gentlemen. 95%. So if I move this to 95, now my interval, think about this, it's going to be a little wider than 90%. So if I do 20 out of 100, it should capture the true mean 95 times. Okay? So looking here, it captured, if you look on the left side here, right over here, it captured the mean all 25 times. Okay, I'm going to do it again. This time, there were 2 of them, it did not capture the true mean out of 50. Okay, looks like now I'm at 73. It captured it 73 times out of 75 and 97 out of 100. So, okay, 97% of the time I did capture the true mean, but my confidence level was 95. So sometimes you might get more. All right. So what does 95% confidence mean? The confidence level of 95% indicates that in repeated sampling, intervals constructed in this way will include the true population mean 95% of the time, or population proportion. Okay, or population proportion. Okay, now that interval was a little bit wider because if you think it's going from negative 1.96 to positive 1.96. So that interval was a little bit wider. Okay, and then the 99%, okay, I'm not going to pull up my little applet there to do that one, but 99%, ladies and gentlemen, that's going to be even wider, right? Okay, that's almost at 100%. Oops, and then I didn't fix this. Fix it right now. So the confidence level of 99% indicates that in repeated sampling, intervals constructed in this way will include the true population mean 99% of the time. And again, our interval is going to be a little bit wider, and more often it's going to be captured. So there's only 1 time out of 100 that it may not capture it. Okay, again, pause if that wasn't enough time because I'm going to keep going here. So again, here's a little picture of what we were just doing with that applet. It's pretty cool. And if you want to play with it, I'll attach it on Schoology. Okay, I don't have it attached yet, but it will be there when you watch this video. All right, let's keep going. All right, memorize this, ladies and gentlemen, page 627. Conditions. Oh, there's going to be a lot of different scenarios and conditions that you're going to need to know. Okay, and you have to have these memorized. Conditions for constructing a confidence interval. The construction of a confidence interval for a population mean mu is appropriate when. So we've got to check these things. First bullet point, the data come from a simple random sample from the population of interest. It has to be a simple random sample. Okay? Simple random sample. The sampling distribution X bar, the sample distribution X bar is approximately normal. It has to be approximately normal. And individual observations are independent when sampling without replacement. So what's good enough for independence here, ladies and gentlemen, is that the population size is at least 10 times the sample size. So the population is 10 times large, it has to be at least 10 times larger than the sample that we take. Right? If you think about the Pfizer and the other vaccine, Moderna, the sample sizes were 44,000 and 30,000. Well, the population of interest is millions of people. So that's definitely okay. And the sampling distribution is approximately normal because the sample size is definitely large enough. All right, and then a simple random sample. Well, they randomly selected people from volunteers. So, all right, let's keep going. So this is the formula we're going to be using, ladies and gentlemen. Okay. X bar plus or minus Z star, the critical value, times the standard deviation. Now, this is the inference toolbox that we're going to be using, ladies and gentlemen. Okay, to construct a confidence interval, step 1, identify the population of interest and the parameter you want to draw a conclusion about. Step 2, you have to check all your conditions. Man. Step 3, then you can do your calculations. Remember, we're getting into formal statistics now, so we got to follow these. Get used to this. Calculations, okay? That's when we're going to figure out the numbers. We're going to find the numbers, and then we're going to interpret, and we're going to use the 3 C's, okay? Conclusion, connection, and context. Now, again, be sure to check these conditions for constructing a confidence interval for the mean are satisfied before you perform any calculations. Okay, just went over those. All right, so you need to know your conditions. All right, I'm going to end with this and then I'm going to go through an example. Okay, so this video is not quite done yet because I got to run through an example. Okay, appropriate sample size for desired margin of error. All right, so remember N is our sample size, and this is our little setup here. But you know what, ladies and gentlemen, this formula is not given to you, so I wouldn't memorize this formula. I'm going to rearrange this. I'm going to do a little bit of algebra quick. Okay, so let me do my Z star. I've got my standard deviation over the square root of N is less than or equal to M. Okay, so what I'm going to do, I want to get N by itself, everybody. Okay, I want to get N by itself. So I'm going to go ahead and multiply both sides by the N squared. Okay, I'm just doing algebra here. They cancel, right? And at the same time, I'm going to divide both sides by M. So I get rid of that. So right now, ladies and gentlemen, I have the square root of N equals Z star times the standard deviation divided by M. Okay, and so what I'm going to do now is I'm going to square both sides. So, ladies and gentlemen, n is going to equal z star times the standard deviation divided by the margin of error squared. Okay, I would memorize that rather than what I have up there. Okay, because that's what I'm going to use. I'm going to go ahead and do an example right now. So if you need to take a break, this would be a good time to take a little break. Come back and watch me go through the example. All right, I'm going to go ahead and get rolling on it right away though. Here we go. So suppose you administer a certain aptitude test to a simple random sample of 9 students in your school and that the average score is 105. From past experience, scores on such a test among students, students like those at your school follow a normal distribution. Ooh, okay, it's telling us, folks. That's important. It's telling us. So our sample is 9 students and the score is 105. We want to determine the mean score mu of the population. Assume a standard deviation of 15. Notice it's giving us sigma for this test. All right, so first thing. What is the upper critical value for a 98% confidence interval? All right, ladies and gentlemen, so we're going to go to our table and we're going to go to 98%. This is table B, and right here, ladies and gentlemen, 2.326. Okay, that is our critical value. Oops, wrong button. There we go. All right, so the Z star here, ladies and gentlemen, is going to be 2.326. Now, you can always round that off, ladies and gentlemen. We can always round off our Z's to 2 if we want. I'm going to go ahead and just use 2.33. So my 98% is going to go, okay, I'm going to say right here is about negative 2.33. And here's positive 2.33. And that would be my 98%. Okay, that's all number 1 was asking about. All right. Next, construct and interpret a 98% confidence interval for the mean score mu. Follow the inference toolbox. All right, ladies and gentlemen, so step number 1. Okay, we need to write this out. So let me make this a little bit smaller. All right, we are interested in estimating just a sec while I get my symbols here. Oh, I need my Greek letters. There we go. We are interested in estimating mu, the mean aptitude score of all students in the school. Okay, that's step 1. Step 2. Okay, we have to check for the simple random sample. Okay, so we are told that we have a simple random sample. You actually need to write that out. Yes. Okay, the next part is normality. Okay. Okay, come on. Oh, then I want red. You know, it's not cooperating with me. All right. The sample is small but the population of the aptitude test is approximately normal, so our sample size will still work. Okay, we have to, if it did not say that, ladies and gentlemen, we would have to say something different. We'll worry about that later. Okay, but the sample size is small, but the population of the aptitude test is approximately normal, so our sample size will still work. All right, now independence. All right, independence. So let's see. The random sampling should help ensure the independence of the 9 aptitude test scores. Also, the student population N is greater than or equal to 9 times 10. 90. All right? At least we're assuming it is. Okay, we are assuming it is. So step 1, what are we interested in doing? Step 2, we got to check the conditions. 3 conditions. Simple random sample. Okay. Normality. Okay, is it normal or not? If it's not, we'll talk about more of those things, situations later. And then independence. Okay. Now, after doing all of that, we are now on step 3. Here, let me do this real quick. So this, ladies and gentlemen, this was step 1. All of this was step 2. Okay, now step 3, we're going to do the calculation. So here we go, step 3. All right, so x bar plus or minus z star times the standard deviation divided by the square root of n. All right, our x bar is 105, ladies and gentlemen, plus or minus. Okay, the z star we found to be 2.33 times the standard deviation they told us is 15. Our sample size is 9, so the square root of 9. Again, the math is pretty easy here, folks. Okay. So when you do this, ladies and gentlemen, you're going to go ahead and do the right. So this is how I do it. Okay, I do the right side. I go ahead and do the 2.33 times the 15. Notice I'm using parentheses divided by the square root of 9. You really would not have to. You could just put a 3 there. And so we're going to get 11.65. So now we're going to take 105 and we're going to take away the 11.65. That's our lower end, ladies and gentlemen. And then we're going to take the 105 and we're going to add 90 or 11.65. And that's going to be our upper end. So 93.35 to 116.65. So that is our 95% confidence interval. So 93.35 to 116.65. Okay, that's step 3. Step 4 is our conclusion, right? We've got to practice writing conclusions, ladies and gentlemen. All right, so here we go. So we say we are 98% confident that the mean aptitude score of all, remember we want to say, we're wanting to tell about everybody, right? Okay, of all students in the school is between 93.35 and 116.65, period. So that's what this is telling us, folks. That's what we can conclude. We can conclude, sorry about that, okay, that we are 98% confident that the mean aptitude score of all students in the school is between 93.35 and 116.65. Now, separate, I can also say we are using a method that captures the true population mean 98% of all possible samples of this size. Okay, and last, oh, that was that part. Sorry about that, folks. That was that part. Sorry, let me redo that again. Okay, explain the meaning of the 98% confidence. So let me just do it again. We are using a method that captures the true, oh my goodness, population mean 98% of all possible samples. Notice how detailed it gets of this size. Come on, S, there you are. All right, and last, wrap this up. Oops, I think it's still on that page. Number 4, we are going to, what if we want, okay, what sample size would be needed to have a margin of error of at most 4 points, still with 98% confidence? Show your work. Now, if you remember, I redid that and I said the sample size is going to equal the Z star, okay, times the standard deviation divided by the margin of error squared. All right. So our Z again is 2.33. We're going to multiply that to the standard deviation. Now our standard deviation again was what? 15, right? Okay, and now our margin of error, we want it to be at most 4 points. So I'm going to go ahead and put a 4 right there. Okay, I don't know if that shows up on yours. All right, so what I'm going to do now is I'm going to take my calculator. I don't know, I guess I can't get the whole thing in there at once. So I'm going to go ahead and I am going to take the 2.33 times the standard deviation, which is 15. Okay, I'm going to divide that by the new margin of error, which is 4 points. And I'm going to close it and I'm going to square it. And ladies and gentlemen, 76.34. So n equals 76.34. That's my new sample size. Now, obviously we can't have part of a person or part of a score. So here's a rule for sample size, folks. Always round up. So 77. Okay. We don't apply rounding rules when we're talking about sample size. If you get a decimal, just always round up. All right, I'm going to do more of this in the next video. So if you didn't quite get that, and I'm going to do it during class with a problem. If you didn't quite get it, we'll be doing it again, ladies and gentlemen. All right, this video is plenty long. It's over 46 minutes. All right, see you soon, folks.